All right, this is your old pal Mr. Cook back with the back page of 2.1. So we just did 2.1 on a separate video. We went through the whole first page. Now we're going to go through the second page. And this is where we need to do polynomial long division. So polynomial long division, it's kind of a pain to work through, admittedly, but the nice thing is that it works on any polynomial that you want to divide out. That's different from synthetic division, which is an easier process, but it only divides out binomial expressions. But again, they're still pretty easy, and it's just polynomial long division is very comparable to regular division that you do, like between numbers. So if I had something like 127, and I wanted to divide that by, say, like 5, okay, 5. Then the process that I would go by is that I'd try to make this 5 look as close to 12 as I can. So by using the powers of 5, 5 times 2 would be 10. So 10 would be the closest number to 12 that I could get to. So to get 10, I'd have to multiply 5 by 2. So 5 times 2 is 10, so I get a 10 here, and then I'd subtract it. All right, so I'm always going to be subtracting the number that I get from this similar number that I started with. 12 minus 10 gives me 2. Then I drop down the next number, and that gives me a 7. So I try to make this 5 look like 27 as close as I can through multiplication. So the closest number that it gets to is 25. So I'd take 5 times 5, and I'd get 25 down here. And I'd subtract that away as well. So 27 minus 25 gives me 2. And since I can't make 5 look like 2 by multiplying it by any like integer values or any whole numbers, then that's just what I call my remainder. So in other words, what happens is what I've done is I've taken 127 and divided it by 5. And the answer that I get from dividing it was 25. That's the number that I get when I divide it out, so 25, with the remainder of 2 from my divisor of 5. So that means it's going to be 25 plus 2 over 5. So it's 25 and 2/5 would be my answer from dividing this out. So this division algorithm that you guys learned back in grade school is going to be the same thing that we're going to do with polynomials. It looks a little bit different, but it is actually the exact same steps. And so I'm going to do all of these, and I'll show you how it connects back over to just this regular old division that we've been working on. Okay, so check it out. We started off the same way that we did with the numbers, and that's just to put the number that we're dividing into inside the little division symbol. So 2x to the third power minus 12x squared minus 9x minus 37. So all that goes under the division symbol. And then the number that we're dividing into that polynomial is this x minus 7. So what we need to do, very similar to this where we made the 5 look like the 12 here, we need to make this x look like our lead value, basically, our lead coefficient or our lead term by means of multiplication. So here's a really easy way to find that first value that you need to multiply to get to. Okay, so I need to make this x look like 2x to the third. So I'm looking for some number that I need to multiply times x to make it look like 2x to the third power. So what you can do is get the number all by itself by dividing out the x. So if I divided both sides by x here, I would get that the number that I'm looking for is equal to 2x squared, because I've taken one of those x out of there. So this number, 2x squared, is the number that we need to multiply this x by to get it to look like 2x to the third power. So check it out. So this 2x squared I'm going to distribute into x minus 7. So 2x squared times x is 2x to the third power. 2x squared times negative 7 is going to give me a negative 14, and then it's x squared. And just like what we did over here with this division, once we got that number that looks really close to the number that we're trying to divide out, we subtract it away. So we're going to subtract this entire thing away. Very important. Please remember to put parentheses around this part of it, because that negative has to distribute into both of these terms, okay? So the negative distributes into the 2x to the third, and it also distributes into this negative 14x squared, so it turns it into the negative turns this into a plus. So now all we need to do is just add these straight down to get our first remainder value that we can then, continue with the division algorithm. So if you've done this correctly, the 2x to the thirds should cancel out every single time, or that first value should always cancel out. So then we're left with the remainder. Let's see what we get. So negative 12x squared plus 14x. Well, 14 minus 12 is a positive 2, so we get 2x squared left over. And once you get that number that's left over from your division algorithm, you drop down the next number. So I'm going to drop down the next number, which is negative 9x. But again, I want this x minus 7, or in this case it was this 5, to look like this number. So I'm going to use x minus 7 again and make it look like this number as best as I can. So I'm going to try and make this x into this first number, 2x squared. So I can do the same thing that I did over here. I'm going to try and find some number that multiplies times x, and it makes it look like this 2x squared. So how do I do that? Well, I can divide out the x from both from both sides here, and I get that number that I'm looking for is equal to, let's see, divide by x, I get 2x squared divided by x is just 2x. So that's going to be the next number that I'm going to multiply in, positive 2x. So 2x times x is 2x squared. 2x times negative 7 is a negative 14x. And we're going to subtract this whole thing away, because that's just part of the division algorithm. It keeps subtracting the values away. So I'm going to distribute the negative in here. Negative 2x squared. Negative times the negative is a positive, so I'm adding on 14x. So if I've done this correctly, then these 2x squared should cancel out, and I'm just left with 14x minus 9x, which gives me a positive 5x. So now that I have my remainder, I drop down the next number, which is negative 37. And I start the process over again. I need to make this x look like 5x, so I need to find some number that multiplies times x to give me 5x. Well, if I divide both sides by x, I get that number. That number is just equal to 5, because the x's cancel out right there. So that's the last part of the division over here, is that I get a plus 5. So I multiply the 5 into both of these. 5 times x is 5x. 5 times negative 7 is a negative 35. And then once again, very important, parentheses around it and subtract. So 5x minus 5x is going to cancel out. The negative here distributes onto the negative here, so I get plus 35 minus 37. So 35 minus 37 is negative 2. And since I don't have any more numbers to drop down, this is my remainder. So my answer is going to be this polynomial up top here. So it's going to be 2x squared plus 2x plus 5. And then also this remainder, so plus a negative 2 over whatever I divided by, so x minus 7. So that seems like a lot of work, doesn't it? But you know what? It's the same pattern every single time. So even though that took some work, it's actually the same thing over and over again that I need to do for number 19, number 21, and also number 23 here at the bottom. So I'm just going to keep doing that same pattern over and over and over again until I get my answers. So for number 19, same thing, just put it under the division symbol, 24x to the third minus 39x squared minus 66x minus 18. And then my dividing polynomial, or my dividing binomial, I guess here, is 8x plus 3. So I need to make this 8x look like this 24x to the third. So, I can do that little pattern thing that I did up here where it's just, I needed to take some number and multiply it by 8x to get it equal to 24x to the third power. So if I divide both sides by 8x, what do I get? Well, the number is going to be equal to 24 divided by 8 is 3. X to the third divided by x is x squared. So that's the number that's going to go up here, 3x to the second power. Now I'm going to distribute this into here, and I should be able to cancel out that 24x to the third if I've done this correctly. Let's see. So 3 times 8 is 24. X squared times x is x to the third. And then distribute it into here as well. 3 times 3 is 9, so plus 9. And then x squared is just, what it is, so x squared. So nothing terrible there. Now just go ahead and put the parentheses around it, put the negative in front, and add straight down. So 24x to the third and 24x to the third cancel out. The negative of positive 9x squared turns that into a negative. And if we have negative 39 and negative 9, that gives us a total of negative 48x squared. Next, I drop down my next number, which is negative 66x, and I start the algorithm again. So I need to make this 8x look like negative 48x squared. Okay, so this might take some work. Let's see. So I need to take some number, multiply it times 8x, and my number should be equal to negative 48x squared. So I just divide both sides by 8x and figure out what that number is. So that number is going to be equal to, let's see, negative 48 divided by 8 is negative 6. X squared divided by x just gives me a regular old x. So that means that the number that I'm looking for is negative 6x. So now I distribute this into my dividing polynomial. So negative 6x times negative 6x times positive 8x is going to give me a negative 48x squared. Negative 6x times a positive 3 is going to give me a negative 18x. So I put parentheses around it and put the negative on it. So the negative distributes in here, and this becomes a positive 48x squared. The negative distributes in here and turns out to a positive 18x. So if I've done this correctly, the negative 48x squared cancels with the positive 48x squared. And then I just simply add these two together. So let's see, 18 minus 66 is going to be a negative 48. So I have negative 48x. And then I just drop down this 18, this negative 18, and start the process one more time. So I need to make this 8x look like negative 48x. So I take some number, multiply it times 8x to get negative 48x. So if I divide both sides by 8x, the x's cancel out. And then negative 48 divided by 8 is negative 6. So that's the number that goes up here, minus 6. Distributing it in there, negative 6 times 8x is a negative 48x. Negative 6 times positive 3 is a negative 18. And this is pretty nice because when we distribute the negative in there, this turns into a positive 48 and a positive 18. And both of these cancel out. So that means I'm left with a remainder of 0. So that means that these evenly divide into each other. And it also means secretly that this is a factor of this cubic expression right over here. So when we divide these two out, we end up with 3x squared minus 66x. Oops, wait, I was looking above it, dang it. So minus just 6x there, and then minus 6. So that's our polynomial when we're all done. We don't have any remainder at all, so we don't need to do any of this stuff that we did in the previous problem. Number 21, we're going to go through the same pattern. So we divide, and then, oh, look at this. We've got 5x to the fourth minus 52x to the third. And then how many x squareds do we have? Oh, there aren't any. So that means that there's 0 x squareds. We actually need to account for that in here. This is what we call a placeholder. So even though we don't have an x squared, we're going to account for it on here because the numbers that keep dropping down need to stay in successive order, okay? So we need to make sure that all of the terms are accounted for. So if there wasn't like an x here, for example, I put plus 0x. But there's a 48 x's, and there's also minus 26. It's even down to the constant value if you want to keep with the division algorithm. You even need to do a constant if you notice that it's something that's not accounted for. All right, but anyways, other than that, it's the same thing that we've been doing before. So 5x minus 2 goes over here. We need to make 5x to the third look like 5x. So if we have some number times 5x is equal to 5x to the fourth power. If I divide out the 5x from both sides, I get that the number that I'm looking for is equal to, the 5's cancel out, and I just have x to the third. So that's the very first number that I have. I just distribute x to the third in there. So I've got 5x to the fourth power, and then negative 2 times x to the third is a minus 2x to the third power. So I'm going to subtract this away. So this becomes negative and this becomes positive. The 5x to the fourths cancel out. And then I've got negative 52 plus 2, which would be a negative 50x to the third power. And this is going to seem weird, I know, but you have to drop down that 0x squared as well. So now we need to make that 5x look like this negative 50x to the third. So we do the same thing that we practiced before. So some number times 5x is supposed to look like negative 50x to the third power. So we divide both sides by 5x. So we get that that number is going to be equal to negative 50 divided by 5 is negative 10. X to the third divided by x is x squared. So negative 10 x squared. So I distribute that in here. I get a negative 50x to the third power. Negative 10x squared times negative 2 is a positive 20x to the second power. And then I put parentheses around it and subtract it. So this turns into a positive 50x to the third, and that turns into a negative 20x squared. So if I add these up, the 50x to the thirds cancel out, and I'm left with just regular old negative 20x squared. I drop down the next term, so plus 48x. And then I need to make my 5x look like this negative 20x squared. So I say that some number times 5x needs to be equal to negative 20x squared. So then, let's see, divide both sides by 5x. And I get that my number is going to be equal to negative 4x, because x squared divided by x is just x. So minus 4x goes there. And then I multiply the negative 4 into this stuff, so negative 4x times 5x is a negative 20x squared, which is what we want to cancel out. Negative 4x times negative 2 is going to be a positive 8x. All right, so we put parentheses around it and subtract it, so this becomes a positive 20x squared, and this becomes a minus 8x. So the 20x squareds cancel out, and I'm just left with 48x minus 8x, which gives me 40x. And then drop down the last term. So this is the last part of the division that we're going to need to do. We need to make the 5x look like a 40x. So some number times 5x has to be equal to 40x. And if we divide both sides by 5x, the x's cancel out. And 40 divided by 5 is just simply positive 8. So you have to multiply everything by 8. 8 times 5x is a 40x. 8 times negative 2 is a negative 16. Put the parentheses around it, subtract, so this becomes a negative 40x, and then this becomes a positive 16. So the 40x's cancel out, and 16 minus 26 is a negative 10, so this is our remainder. So when we write out our polynomial, as it's all done, it's going to be x to the third power minus 10x squared minus 4x plus 8, and then we have plus negative 10 over our divisor, which is 5x minus 2. There's our polynomial after it divides out. So since it doesn't divide out evenly, we can state without any difficulty that 5x minus 2 is not a factor of this polynomial. All right, now for the very last one. Oh boy, so we go all the way up to the fifth power on this one. So we're going to need a little bit of space, so I'm going to write into this area a little bit probably. Especially to write out my answer when I'm all done. But anyways, other than the fact that it goes up to the fifth power, it's the same steps as we started. So it's 7x to the fifth plus 16x to the fourth, and then minus 15x to the third. We don't have an x squared, so that means we have to have a plus 0x squared plus 42x minus 25. One thing that you can do to check to make sure that you're on the right track before you start up with your division algorithm is make sure that all the powers are accounted for. X to the fifth, x to the fourth, x to the third, x to the second, x to the first, and then x to the 0, just the constant value. We're dividing out 7x minus 5. So let's start up this algorithm. I'm not going to, I'll do all this stuff. But I mean, after a little bit, you can kind of guess what the number is going to end up being that you have to multiply. But it just takes a little bit of practice. I'll keep writing them up over here, but you don't have to do it every single time. So I'm supposed to make 7x look like 7x to the fifth power. So I need to multiply by some number. Let's see what that number is. So I divide both sides by 7x. The 7's cancel out. X to the fifth over x turns into just simply x to the fourth. So that's the first number that I need to multiply in there. So distributing it in there, I get 7x to the fifth power. And then x to the fourth times negative 5 is negative 5x to the fourth power. Put parentheses around it and subtract. So this becomes a negative 7x to the fifth. This becomes a positive 5x to the fourth. So those cancel out, and then 16 plus 5 gives me 21x to the fourth. Drop down the next term, negative 15x to the third. Now I need to make 7x look like 21x to the fourth. So I need to multiply by some number. Let's figure out what that is by dividing both sides by 7x. So 21 divided by 7 is 3. X to the fourth divided by x is x to the third. So that means that the number that I'm going to multiply in next is going to be a positive 3x to the third power. So 3 times 7 is 21, so I get 21. X to the third times x is x to the fourth. 3 times negative 5 is a negative 15, and then x to the third right there. Well, that's pretty neat because that means that these are all going to cancel out, because since they're the exact same thing, the signs are going to cancel each other out, and I'm just going to be left with a 0. And this is great because I have 0x to the third, then I can drop down my 0x squared. So I still don't have anything that I need to turn this 7x into, so next I'm going to drop down the 42x. So now I finally have something that it needs to look like. If you want to kind of rationalize the steps that we've been going through, think about it like this. How do I make 7x look like 0x to the third? Well, I need to make some number times 7x equal 0x to the third power, right? Well, the only way that I can do that, if I divide out the 7x's here, well, the x cancels out, and I just have 0. Right, because 0 over 7 is 0, so that means that the number that I'm looking for is 0x squared. So this is plus 0x squared, so nothing. And then I drop down that, and then I need to make the 7x look like 0x squared, so I divide out the 7x. And then one of the x's cancel out, and then 0 over 7 is still 0, so I have 0x for that one. So everything times 0 still gives me 0. But this 42x is finally something that I can turn that 7x into. But I don't have a second term to pair it with. So I'm going to drop down the negative 25 as well. So that's what I need to make that 7x look like now. This is really complicated, isn't it? But you know, when you get a bunch of zeros, you get zeros for your answer up here. So it's not terribly difficult to kind of rationalize that. Again, just think back to like over here. How do I make 7x look like 0 anything? I multiply it by 0. 0 is the number that goes out front there. So how do I make 7x look like 42x? Well, I need to multiply it by some number. So I divide both sides by 7x. So the x's cancel out, and that means that the number is just going to be equal to 42 over 7, which is 6. So that's the last number that I get there, 6. So if I distribute the 6 in here, 6 times 7x is 42x. 6 times negative 5 is a negative 30. Put the parentheses around it and subtract it. So this changes this to a negative 42. This will change this to a positive 30. So the 42x's cancel out, and then 30 minus 25 is just simply 5. So this is my remainder because I can't go any further than that. Now to write up my answer, so I've got x to the fourth power plus 3x to the third power plus 0x squared plus 0x. I'm just going to leave those out. So the last thing that I have is that plus 6, and then I have a remainder of 5. So plus 5 over my divisor, which is 7x minus 5. And just like that, I've got the solution for my division. So that's all of the odd numbers from 2.1. And yeah, now we're going to move on to synthetic division, a much easier process, and we're going to start that up in 2.2.